Hi, my name is Richard and I'm from Seneca Learning. Today we're going to look at our second section on vectors. If you want to see the first section, please look at the other video for a bit of an introduction. So let's get going. So vectors as translations. Vectors can be used to represent translations of shapes or points. The number on the top tells us the units to the right or left if it's positive or negative. So right if it's positive, left if it's negative. And the number on the bottom tells us how many units up or down it goes. Again, down if it's a negative number, up if it's a positive number. So for example, this translation here would move the shape 3 coordinates to the right and 1 down. So if we take point C here, it would go 1, 2, 3 across to the right in the positive direction and 1 down in the negative direction. And then that shape would move to there. So let's have a look at some questions. So the top number means the horizontal direction. So this vector would move the shape 3 units to the left because it's a negative number. And likewise, the 4 on the bottom, it would move it 4 units up. And positive, up, negative, down. I'm just going to skip this video because you can watch it in your own time if you want to. So you can also look at what you call scaling vectors. So here you've got a vector 3, 2, and this 5 in it basically means I want 5 of these. It's almost like a multiplication. So what you can do actually to work out what the total value of 5 of 3, 2 is simply times the numbers within the vector. So 5 times 3, you'll see will give you 15. 5 times 2 will give you 10. So the overall vector of 5 times 2, 3 would be 15, 10. So to show 3 points A, B, and C lie in a straight line, what you need to do is you need to show that AB is what we call a scalar multiple of BC. So to make sure they're on the same line, basically what we're saying is this direction is the same as this direction, it's just this BC area might be a bit longer. So if you're given side lengths in ratios, you can use it to translate into vector form. So the ratio of AB to BC in this situation would be 2 to 3, and A, B, and C are in a straight line if the numbers are a multiple of each other. So here we've got 2AB is equal to 3BC. It's going to be the same direction, it's just that it's going to be different lengths in each situation. So what are the conditions for A, B, and C to be lying in a straight line? So AB is a scalar multiple of BC, so like we just talked about. Again, another video, I'm just going to skip over that. You can watch it in your own time if you'd like to. So back to this, negative 9 would move it to 9 units to the left, and the negative 4 would move it 4 units down. What is the condition for points X, Y, and Z lying in a straight line? So we had this example earlier with A, B, and C. So X, Y is a scalar multiple of Y, Z is the necessary condition. Again, so let's think about this. Move the shape 10 units to the right, and it would move it 1 unit down. What happens to the vector when it's multiplied by a negative scalar? Well, if we're going to multiply by a negative number, what will happen is all the numbers within that vector will change. If it's a negative, it's change to positive. If it's a positive, it will change to a negative. So what that'll actually do is actually change the direction, reverse the direction, in fact, of that. And let's look. So 100%. Fantastic. And I'm going to store my memory in Lake Ohrid in Macedonia.